Okay, so welcome back everyone, and today is day 622, and we will be solving this question. There is sum of I will be solving this question. There is sum of subarray ranges, right? तो ये question क्या कहता है? We've been given integer array. The range of the subarray is defined as the difference between the largest and smallest possible elements within that subarray, right? So assuming we have this subarray as 1, 2, and 3, right? So what would be, we need to form all the possible subarrays. If we talk about the brute force approach, then I need to form all the possible subarrays. So what I will do is that I will basically form all the possible subarrays, and it would be 1, 1 comma 2, 1 comma 2 comma 3, then it would be 2, 2 comma 3, and then 3, right? So I need to return the sum of the largest minus smallest of each possible subarray, right? So the brute force approach would look like that I go from I equals to 0 till I less than n, I plus plus. Then I start a loop from I j equals to 0, j less than n, and j plus plus, right? And I declare one more variable here, that is min and max, right? To track the minimum and maximum, I declare it, that is, if I want to track the minimum, I declare it with plus infinity. To track the maximum, I declare it with minus infinity, right? Here I will just say that my minimum is nothing but math dot min of min comma array of j, right? And my max is nothing but math dot max of max comma array of j. That is it. And for each subarray we need to return the maximum plus equals to max minus min value, right? And this for loop ends here, this for loop starts here, ends here, and I just return the answer for this one, right? What would be the time and space? O of n square as time and O of 1 as space, right? Let's just see the code in action as well. तो ये मेरा editor है, and I'm submitting this code, and definitely I'll get a TLE. Why so? Because yeah, constraint is 10 power 6, right? And definitely we got the TLE. Constraint is 10 power 6, that means, and I'm using O of n square, so that means 10 power 6 whole square is 10 power 12, which is greater than 10 power 8, and that is why you hit the TLE. If you want to understand the constraint, then I already recorded one video, that is trick the TLE by Akshay, and this would be sufficient to understand the TLE thing. Coming back to the second, or the brute, or let's say the optimal approaches, right? This optimal approach will require a lot of constraint, but I have done it in past, and that's why it was easy for me to solve this question, right? What is the intuitive, what is the idea to solve this question now? So if we see the same array, let's say 1, 2, and 3, right? And okay, and if I for all the possible subarrays, if I calculate the maximum sum of subarrays, maximum element sum in each subarray, whatever that element is, I found the sum, I found that element, the largest element, that subarray, and then make a sum out of it, right? Similarly, I got the minimum sum of subarrays, right? So this value is, let's say, x, this value is, let's say, y. X minus y will give you your answer, right? इससे हमारा आंसर मिल जाएगा. So एक छोटा सा ड्राइंग करके मैं देख लेता हूँ तुरंत से. So 1, 2 and 3, right? So the number of subarrays, and the subarrays forming would be 1, 1, 2, 1, 2 and 3, 2, 3 and 2 and 3. So the number of arrays having this element as maximum, and number of subarrays having this element as minimum, right? So this element यहाँ पे क्या होगा? This element would be 1, 2 and 3. I can clearly see the number of subarrays where the 1 is maximum is this one, 1, and that's it. So it would be 1. Similarly, number of subarrays where 2 is maximum is 1, 2 and 2. So it is 2. Number of subarrays having this element as maximum, that is 3, which is nothing but 1, 2, 3, 2, 3 and 3, that is 3, right? I can say the maximum contribution I get is 1 into 1 plus 2 into 2 plus 3 into 3. That is 9 plus 4 plus 1, which is 13. And the number of sub-arrays having 1 as minimum is nothing but just this one. So it will be 1. And the number of sub-arrays having 2 as minimum, there will be nothing but 2 and 2, 3. So 2. And number of elements having 3 as the minimum, which is nothing but this alone 3, which is 1. So the minimum sum contribution I got is 1 star 1 plus 1 star 1 plus 2 star 2 plus 1 star 3, which is nothing but 10, right? 1 star. Okay. Number of sub-arrays having this element as minimum, that is the 1 as minimum. तो ये 3 sub-array हुए, यहाँ पे 3 होगा. So 1 star 3, 2 star 2, so 3 plus 3, 6, 6 plus 4, 10, ठीक है. And my resultant answer is nothing but the maximum sum, that is 14 minus 10, which is 4, and 4 is our expected output as well. So the whole question boils down to how do we find this particular problem? How do we solve this particular problem? And to solve this problem, I have already read what is next, how to find next smaller for every element in an array, and next greater, and similarly next smaller and previous smaller element, right? Why I am saying so? Why I am saying so is, let me take a good example. Okay, this example would do. So 3, 1, 9, 5, 4, 6, 2, 0, 3, and 7. I'm talking about this element 6. Let us name this element index as I. And I'm going to find that for all the sub-arrays, for this 6 is maximum, right? So 6 and 2 would work. 6, 2, and 0 would work. 6, 2, 0, 3 would also work, but 6, 2, 0, 3, and 7 would not work because the 7 is the largest. So I would name this my next greater index at j, right? And previous greater index, as a 6 and 4 would work, 6, 4, and 5 would work, 6, 4, 9 would not work, right? So 9 as k, right? So I got 4, 1, 2, 3, 4. 4 elements to the right hand side, and 1, 2, 3. 3 elements to the left hand side, right? How many sub-arrays would be formed here? It would be 3 star 4, right? And in this sub-arrays, what is the contributing element? Which is 6. So 3 star 4 star 6, which is nothing but 12 into 6, which is 72, right? So the maximum, or let's say the sub-arrays, number of sub-arrays which has this 6 as maximum, उसका contribution हमारे पास 72 होगा, ठीक है? 3 star 4 कैसे लिखा? अगर हमारे पास कुछ लेट्स से इस तरह का एलिमेंट है 1, 2 and 3, एंड दिस इज द कॉमन एलिमेंट, ये एलिमेंट सब में होना चाहिए. व्हाट वुड बी, एंड हम इसको कवर करते हैं और इसको भी कवर करते हैं, राइट? व्हाट वुड बी द नंबर ऑफ सब एरेज फॉर्म? दैट इज आई कैन फॉर्म 2, 3, आई कैन फॉर्म 1, 2 and 1, 2 and 3 and a simple an alone 2. तो अगर आप देखोगे, so 2 element was in the left hand side and 2 elements I considered in the right hand side. So the number of sub-arrays is 2 into 2, and which is 4. So 4 sub-arrays, we got it. So all I need to do is to find the next greater element and previous greater element index, right? Once I have that, so let's say this is j, this is k, then what I'm gonna do is that I'm gonna say j minus I into I minus k into my array of I. This would be the contribution, right? I need to do this for all the elements, and we would be getting we would be solving this question. Which question? Number of, no, not this one. Maximum sum of sub-arrays, right? So this would consider a lot of question. Maximum sum of sub-arrays would be solved by this, right? Previous greater and next greater, I have already done it past, so I'm not gonna record a video again where I have done it in past. Just day before yesterday, we have a stock span problem. I explained the previous uh, greater element. How do we find it? So that's the pseudocode here. We would be using the same code, the same exact code. And in day 87, right, I covered the next greater element, right? Do check it out, because I'm gonna copy the same code. I'm not gonna record it again. Going back to the question, a small enough intuition for solving the minimum sum of subarrays, right? So what are the things we require in this one? What are the things I require in this one? So I'm taking the case as, let's say, 146254001, right? Let's say I'm at this point, index I2. I can basically consider these two elements in the subarray where 2 is minimum. I can consider this as well because 2 is minimum. And 2540, I cannot consider this one because we have found element which is lesser than my current element. So this would be my index k. And again, going in the left hand side, so it would be 26, okay, 264 will be okay, 261 not okay. So this would be my let's say this is j as the naming convention, and this is k. So again, j minus I star I minus k star array of I. I need to do this for all the element in this particular array, and we will be getting, and obviously summing those particular answers, and we'll be getting the minimum sum of subarray. What I need to solve this question, I need to find previous smaller, right? I need to find next smaller, and all this can be done in O of n via using stack. We already know that, as time as O of n and space is also O of n, right? O of n. So we're gonna code all this thing. Next greater element already done, previous greater element already done, these two already done with some similar tweak, and at last we're gonna take the contributions from both hand side, right? This will work, and I'm gonna solve this question, today's question, by this approach. Coming back to my code editor, and I can see, so this is the code I have written. So int n equals to i.length, and we have a left min to track the previous smaller, as the name says, right min to track the next smaller, left max to track the previous larger, right max to track the next greater element. And obviously we need a stack, so I made one stack. And again, the actual answer is nothing but the sum of max subarrays minus sum of min subarrays, right? And the sum of max subarray is nothing but for each element at index I, we need to find the previous greater element, let's say at index k, next greater element at index j, and total number of subarrays having array of I as max will be I minus k star j minus k. Total contribution for this element would be I minus k star j minus k. No. One second. That's right. So the contribution will be again the number of subarrays formed into the actual element. Previous greater, that's the link of the video. I can go through in future if you want, since I've already solved it. So I'll just use the same code here and st.clear. Now we get the next greater, that is, we'll be storing the right max array of I for each and every element. And again, we do st.clear because I needed to find the next things, that is, for some of the minimum subarrays I need previous smaller, so I'll be using the same code with some similar tweak. And previous smaller is covered, next smaller is covered, and st.clear, and that is it. And at last but not the least, this would be the final contribution, that is answer equals to 0. And the maximum contribution was again left of max of I into right of max of I into array of I, and minimum contribution would be left min I into right min I into array of I, as we discussed in the dry run, as I showed in the dry run. So this is nothing but the answer plus of max contri minus min contri, and at last I returned the answer, and this code should work. What would be the time and space again? So time would be, we are using a four parallel for loops, right? And all the operations will take O of n, O of 4n, ignoring the constants. O of n, that is O of 10 power 6, which is less than 10 power 8, and that is why we got a successful summation. Time complexity would be O of 4n again, ignoring the constant would be O of n, and that goes the expected time complexities. That is for this one. I will solve then tomorrow's question and will record again. Till then, keep learning, keep doing, bye-bye, and take care.